Hi, this is Shuai Liang, and doing the probability and stochastic homework 5, and we continue our homework question number 2. My net ID is an sl5352, and here's my answer to question 2. And the question 2 here asks, given the probability distribution function, the probability density function that is an fxy, and it contains two variables here, random variable here. The form is 1 over a times y squared and times x. And when y is greater than 1, greater or equals to 1, and x is in the interval of 1 over 2, y and y. The first question gives us the requirement of drawing the non-zero definition regions of fy. So pretty much about this question is to just write the regions defined in the question here, that y is greater than 1 and x is in the interval here. So we could probably firstly join the coordinate here, as this line is 1 over x equals to y, and this one is x equals to y. X equals to y, and x is less than y, so oh my god, x is less than y. Yeah, x is less than y, so give them upper places of here, and x is also greater than the 1 over y, which means in the uppercase of here. So all of the shaded region given the non-zero definition regions of fxy. So the second question here, find a so that fxy is a valid joint density function. The only numerical relationship we got at fxy is that to integrate out the x and y on their definition field gives us 1 when that is a total event, which means whole with all of the possibility here. So what we can do here is just to write the two-dimensional integral here, that is from minus infinity to plus infinity, and fxy, dx and dy. And during the computation here, we could write an exact integral here we needed, which means x is from the x is actually from the 1 over y to y, and that is the inner integral, and the outside integral is from y from 1 to the plus infinity. So that is pretty much easy to compute. We could actually doing this computation easily to here, this step, which also is easy. And coming to this step, I was thinking that one way to do it is just using the step integral as a means of doing this separately. But I'm not thinking that is a cool way to do that. So I just suddenly find that if we let the ln y equals to k, which means y equals to the e to the power of k. So that probably gives us a great idea of how to compute this later on. Just write it over here, which is the same form, and just change the ln y to k, which is the things the integral is 2 over a times e to the power of 2k and times k, d e to the power of k. E to the power of k is still the e to the power of k and dk, right? So we could rewrite the form as this. And coming to this place, we could easily find that this is actually the exponential distributions form. So this part equals to 1, and this whole part is equals to 1, so which probably very easy to give us the clue of a equals to 2, that makes fxy is a valid joint density function. Here's the second question, right? And about the third question, find and draw the marginal density function fx and fy. To find the marginal density function here, we could probably just start with one variable, random variable, to sum out or to integral out that random variable, and thus yield the marginal density function here, which is fx and fy. So let's do this. First things first, I'm just started with a minus infinity to infinity about this drawing density function based on the variables y, and that gives me the ends of 0, which is wrong with the computing because y is not actually going from minus infinity to infinity. So change this interval as here. We could probably just doing the same. The first thing is that the x is actually the two bounded by two kinds of y. Y is bounded by two kinds of x, which means if x is from 0 to 1, which means this interval, that you could probably see that y is from actually the 1 over x to infinity, to plus infinity. And if x is bigger than 1, which means this part, and the y is actually from x to plus infinity. So this fx could be compute in a different interval here, and they could be added together as in first round of x is in 1 over 2, and second round is in 1 over 2 times an x to the power of 2. Here is an x, but when it comes to the fy, lowercase fy is much more easier than that, because on fy only got one kind of a situation here, which means x is from the 1 over y to the y, so just an integral from that intervals. And this is probably very easy to compute. I'm not going to say that over, but so on and so forth, the same ways of integral things. So the fourth question asks us to verify the fy and fx are valid density function, which also reminds you that you should sum out these variables on their intervals of a definition. So let's do this. X is from 0. This time it's not a y-bounded x, because x is only x, so we're using the x actually could be the numbers of from 0 here, you could see, from 0 to the infinity, as it's right here. So probably very easy to compute that this integral equals to 1. That's correct. And also y here is from 1 to the plus infinity, which is very easy to compute also, and that is 1 also. So we verify the fx and fy are valid, are actually the valid density function. That's probably my answers here. Thank you.